No, they asked me where I was going and I said, we're having steak somewhere, but I don't know where. And then the steak place are popping up. That's my 20th anniversary is Wednesday and my birthday is Saturday. So, but we're going to a friend's house up in Fresno for games and dinner, so I don't know what we're doing. So. What's the day? 19? Not 35, day 19. We're gonna hit 13.2 some more. This is our 3x3 equation section. 3x3 or larger. And when I say equations, I mean system of equations. And we went over a matrix method. We used the matrix method. Which has pros and cons. Pros are you don't have the X's, Y's, and Z's, so you can condense it down really small on your paper. Pro takes up less space. The cons are you need to know what the hell it means, where it's you need to understand what everything is. And that's the first con, but I think the bigger con is it often devolves into fractions. And you know how I feel about fractions. Now, I don't know if that happens on any of the ones that we had as our test subjects. Did anyone try to do the ones I said, hey, try before Tuesday?
I tried the.
We're gonna work on those. And so like this first one, I'm gonna do both ways and you guys can tell me what you like. So let's set up our system real quick. We had 3x minus y plus 2z equals 2. 4x plus 2y minus 7z equals 0. And 2x plus 3y minus 5z equals 7. In matrix form, this looks like this. Oop. Okay, so let's do the matrix form first. So step one is make the upper corner a 1. By dividing the row by its value. So if I divide everything in that row by 3, I get 1, negative 1/3, 2/3, 2/3. And then I have 4, 2, negative 7, 0, 2, 3, negative 5, 7. Then, step 2 is add multiples of the first row. To the other rows. To get zeros in that first column. Okay, so to do that, I need to do, to cancel this row, I need a -4. So I'm gonna multiply the top row. What I'm adding to row 2 is, I'm gonna do -4 times this top row. -4, +4/3, -8/3, -8/3. And what I need to add to row 3 is -2 of that row. So -2, 2/3. Yeah, 2/3. -4/3. -4/3. So if I do that, my matrix now looks like this. So I should have zeros in these first 2 spots. If I add 4/3 to the 2, this is like 6/3. That's like a 6/3. And that's like a -21/3. So if I add those, 4/3 and 6/3 is 10/3. -8/3 and -21/3 is -29/3. And we're gonna add -8/3 to the 0, and that's just -8/3. And now if I add this to row 3, I got 3 is the same thing as 9/3, so that I can add to the -4/3, 9/3 and -4/3 is 5/3. -5 is the same thing as -15/3. So -15/3 and -4/3 is -19/3. And that's 21/3, so when I add -4/3 to 21/3, I get 17/3. There's the fractions I said that we're gonna have, and we're gonna fucking hate. Let's keep going. Is everyone good with me so far? You said you did this.
I did this,
Did I make a mistake?
no, I just don't understand how we did.
Which part? So if I go further now and you don't know what I did there,
You have to put it,
we're adding multiple, we wanna get one, what we wanna end up with, or so our pictorial goal of what we're ending up with. We wanna have 1, 1, 1, 0, 0, 0. Some number A, B, and C, and then we'll have. Our answer, I'll call this D1, D2, D3 over here. That's the goal.
Okay.
One's along the diagonal, cause then we can back solve. So
Which
that,
I get that, but it's when we're. How do we get those first fractions when we're adding to row 2? Like, I understand we need to do the -4 to get the 0. But then how do we?
so what I was doing was. I did -4 times this row and I wrote down here. And then. I'm adding this to that. Then I added the 4/3. Maybe we'll give a little edge. To the 2. So I changed it to 6/3. So that I could add those two and I get the 10/3.
I still don't know how you got to 4/3.
I did -4 times -1/3.
Oh, cause you had to go to the top row, okay.
Yeah, when I do -4 times the top row, I gotta do -4 times everything in the top row.
That's right. And then the -2, is that also to the top row as well?
I did, yeah, I multiplied -2 times the top row. So that I could add it to row 3. To get rid of this 2. And that's how I got all these values right here. Alright, we got Jackie, is everyone else? Okay. But you may not like it because it's ugly, I agree, it's fucking ugly. Alright, so now that we got. This is just fucking ridiculous. Now that we got. A 1 in the upper corner, now we want to get a 1 right here. So we want a row, or we want a 1. In front of row 2. But after the 0. So if I multiply 10/3 times 3/10, I get 1. Which means multiply. By 3/10. So 10/3 times 3/10 is 1. -29/3 times 3/10. Is -29/10. And 10/3 or 3/10 times -8/3 is -8/10. So that's gonna make that second row. I'm rewriting everything as is. I've got a 0, a 1. A -29/10. And a -8/10. And here I have 5/3. And -19/3 and 17/3. That's a 0. All right. So that was step 3. Step 4 is get zeros below that 1. So I want to make that a 0. Which means I need to add the opposite sign and multiply this by -5/3 of that row. And if I add -5/3 of row 2. -5/3 of row 2 will be -5/3. This is fucking ugly. I'm gonna simplify this a little bit. Let's see, -5/3 times -29/10. That's a 1 and that's a 2. This becomes 29/6. And if I want to do -5/3 of that. 1, a 2, I get 8/6. So that is what I'm gonna add to here. This is fucking tedious, right? I agree. There's a better way. Computers do this really quickly. This works great on computer. If I add that up, I'm gonna rewrite my other rows. If you don't, you will do this method wrong. There is no way to consistently keep things right without redrawing the matrix every fucking time.
So now we're adding that to row 3.
But we're adding that to row 3. I should get a 0 there, 0 there. Alright, so if I wanna add negative 19/3 and 29/6. I'm gonna multiply that by 2/2. So that I have negative 38 plus 29/6. Which is negative 9/6. Negative 9/6 reduces to negative 3/2. Negative 3/2 there. 17/3. If I double that, is 34/6. And I'm gonna add that to 8/6. And I get 42/6, which is, oh, that's convenient. 42/6 just simplifies to 7. And I swear this thing said the answer was 1, 5, and 2, but I'm not seeing it.
It's get lost.
This is fucking pain in the ass, right? You guys are right at. I'm gonna make sure that. I have the right answer. Cause I said it was 152, but I don't see 152. I see it. This is not a 2 coming out of this.
On step 3, were we supposed to only do the one with one cross? The set?
Yeah, cause we're trying to make that a 1.
Yeah, we're trying to modify that.
And so we modified the rest by doing it in that row, but nothing, no other rows. Let me skim what I did so far. Four, 4/3, negative 8/3, negative 8/3. Two-thirds, negative 4/3, negative 4/3, and add that there. 5/3. 21/3, that's 17/3. I do some weird shit here. Now, negative 5/3 of that row. And 38, correct. So negative 9/6 is negative 3/2, that's correct. That's 7. Maybe I wrote down the original problem wrong, that would be a bitch. It's fine, the answer is still doable the way we're doing it, but it just, the problem had easier numbers. You know what I mean? But I'm actually kind of good, it's all fucked up right now. Glad it's all fucked up because I want to show you why this was a pain in the ass. Yeah, it says 1, 5, and 2. We're not getting 1, 5, and 2, there's no way. 42 divided by 6 is 7, right? I'm not tripping out, sometimes 6 is 42. Because at this point. We multiply this row by negative 2/3. Oh, you know what? It might. After you factor out shitty stuff.
Where did the-
So multiply, this step 5, make. That negative 3/2 equal 1. What this is our X column, Y column, Z column. This is our answer column, we now have Z equals negative 14/3. Okay, now what we do is we add multiples of this row upwards. Now go upwards. Sticking in the matrix form, going upwards. So now, new goal. Is we want 1, 1, 1, 0, 0, 0, 0, 0, 0 like that. And then we will have. X equals, Y equals, Z equals when we're done. So to do this, our next goal is to add. Multiple of bottom. To other rows. To make that zeros, make those zeros. So I need to add. 29/10 times row 3 to row 2. And I need to add. Negative 2/3 of row 3 to row 1. What that's gonna do is we're gonna have this at this point. This is negative 14/3 down here. We gotta figure out what the rest is doing that. So negative 29/3 of the bottom row is, or 29/10 of the bottom row. Is ugly as hell. So we're adding 29/10 times negative 14/3. We're adding that. To negative 8/10. I don't know what that is. But I need a common denominator. I'll do 3/3. This is, I don't even know what 29 times negative 14 is, that's fucking ugly already. Calculator. $29 times 14. 406. I have negative 406 minus 24 over 30. Which is negative 430 over 30. Which is negative 43 over 3. Then we need to add negative 2/3 of row 3. So negative 2/3 times negative 14/3. We're adding that to 2/3. To do this, I need a common denominator. The common denominator looks like it's gonna be the 9. So I have 28 plus 6 is 9. This is 34 over 9. There's no way that's becoming a 5. Whoever said that answer was fucking 1, 5, and 2 was lying out their ass. Unless I did some shit wrong somewhere along here. Alright, finally. Make that a 0. So I'm gonna add. A multiple of this row, I'm gonna add 1/3 of row 2. To row 1. So that is a 0, 1/3, 0, and negative 43 over 9. That's what I'm adding. To the top row, and if I do that, my matrix looks like this. Negative 43 over 9 to 34 is. Negative 9 over 9, negative 1. So this says when you get down to the final form. X equals negative 1. Y equals negative 43 over 3. And Z equals negative 14 over 3. That was ugly as hell. Did anyone enjoy that at all? I didn't even enjoy it, and I fucking like math. So if you enjoyed it, congrats. You're even more sick than I am. Let's do this a better way. Let's do this like we did and do it the 2x2s. So let's restart. But do like a 2x2. We did the 2x2s. In fact, if we do this right, it's going to devolve into 2x2. So, does anyone need to have longer? Let me leave it up a little bit longer. There's a lot going on there.
And so I guess you could say this is us making the set of equations 1 to 1. Is that what it says?
Well, remember, these are the coefficients, kind of, but like these coefficients are the numbers in front of x, y, and z. So now this top row says 1x plus 0y plus 0z. So we're just down to 1x.
It's not really that, it's just we eliminated all the other.
Yeah, it's a giant way of eliminating. Alright, so I'm gonna rewrite this. How could that possibly be? 3, negative 1, 2, and 2. 4, 2, and negative 7, 2, 3, negative 5, and 7. They're fucking wrong. Okay. So when we had 2x2s, what did we do?
We needed
Go ahead, Jackie.
a negative and a positive of the same.
Of the same number. We're gonna do that here, but we're gonna do it to 2 different rows. So let's pick a variable to do that with. I personally think I like y here for that. Because y started, one of the rows has a negative y. So I can add multiples of this row to that row. Like if I do times 2 here. I'm gonna, and I'll write it right here, I'm gonna have 6x minus 2y plus 4z equals 4. And so notice when I add these two, the y is gonna go away. Let's call equation this called, let's call this equation A, B, and C. This new one will be D. It helps you if you label them, that way you can track a little bit of what you're doing. So this D was made by doing 2 times A. And if I want to get rid of the 3y here, I need to multiply by 3. So we'll call this E is 3 times A. And that's going to be 9x minus 3y plus 6z equals 6. I'm doing times 3 of that one. So notice that now I got 2y, negative 2y, 3y, negative 3y. I haven't added them together yet. Everyone see that? Everyone go with that? So now if I add b plus d, I get 10x minus 3z equals 4. And if I add c plus e, I have 11x plus z. 7 plus 6 is 13. We're down to 2 equations, 2 unknowns. We want to get down to 1 equation with 1 unknown, so we have a letter and we can back solve. But I want to make sure that soaks in right now, real quick. Is everyone okay with what I did? This should be a lot like what we started with the 13.1. Is a lot easy, no fractions yet, right? Fuck yeah. The fraction shit was part of the biggest part of the tedious stuff in the last one. Plus, you had to go much more slowly and make sure you didn't fuck. Like I had to recheck my work 3 times just to feel fucking confident I had the right answers. I'm pretty sure I did right so far because there wasn't anything hard to do. All right, so maybe we'll call this F and G. I want to add these together such that one of the letters goes away. What's a good choice here to eliminate?
Z.
Let's get rid of Z. Because we've got one is positive, one is negative, and one of them's got a coefficient of 1. Z is a good choice. If I multiply G times 3, I get 33x plus 3z equals 39. Maybe we'll call that H. So now I'm gonna add F plus H. $33 plus 10x is 43x. The z's go away. And 4 plus 39 is 43. And lo and behold, x equals 1. Maybe the answer was 1, 5, and 2, and I fucked up the matrix somewhere. But I checked everything a couple times and everyone was like. No one said anything. I don't know if anyone was doing the math with me though. But I checked my math a couple times.
I got to a certain point where I was like, oh, yeah, you got it, you got it.
Right.
Yeah, but then I understand it.
So it's like, oh, fuck.
So we're doing pretty good. Let's go through and. Let's plug, okay, I'm gonna put a circle around it. Let's plug it into one of these F, G, or H. They all have X's in them. I personally think we're gonna plug it into G and make it look good, so. In G, I now have 11 times 1 plus Z equals 13. So Z plus 11 is 13. And Z equals 2. Yeah, there's a fucking mistake somewhere in the matrix shit.
Yeah, cause I got 1, 2.
And now we go back to an initial row, A, B, or C. To find what? I'm gonna plug these into A. Well, I'm gonna say one of the first 3. It doesn't matter which one you do it in, you should get it. So I have 3 times 1 minus y plus 2 times 2 equals 2. 3 minus y plus 4 equals 2. Three and 4 is 7, minus 2 is 5. Y equals 5. Make it into X, Y, and Z, we get 1, 5, 2. So I don't know what happened with the fucking matrix thing. But I think it doesn't matter. It really doesn't matter because it was wrong. And it illustrated what I wanted to show you. Which one of these methods was easier?
This first one.
This is easier by a long shot, right?
Took a, less pages.
Yeah.
So every new equation that you make, you just slap the letter onto it?
I did it just to keep track of.
Just,
That way, if you're going through it later on, like you're like. Cause we got a bunch of equations going on here, I can kind of track what I did.
Yeah.
Like, especially if I'm doing it on a test. And I fucking do go through the rest of the problems and I come back to it and go, okay, I wanna review my work. How the fuck do I review my work if I've just got fucking let X's, Y's, and Z's and equations all over the place? By doing arrows with letters and like pointing and going and making this, okay, this new equation came from this. I can track what I did. And that way it makes it easier to review. Notice it didn't help me solve. The A through H didn't do anything for the solution. It's more for check your work, so that's worth noting. The A, B, C, down to H didn't help me solve. But will help me check my work later on. Hopefully, none of the problems in the homework ask you to do step by step of the matrix. Hopefully, they're just gonna ask you for the answer. Jackie said she started 13.2 and hasn't seen any sign of that. So that's a good thing, so we can do this from here on. This was by far the fucking worst. That was terrible, and yet. We had our answer. Barely over half a page here. I did fucking 3 pages. For the fucking way that's supposed to take up less room,
yeah.
right?
Quite literally.
All that fraction shit, you're like, you have to have a lot of scratch work going on if there's a lot of fractions. But here, we didn't have fractions, and if there were gonna be fractions, they don't show up until you're starting to work with the solution. Which is always the later you can get them in there, the fucking better. So I don't know where the matrix went wrong, and I really don't care. Cause I wanted to show you guys this method anyways, cause I thought you were gonna like it more. Alright. Let's take a look at another one.
Question, is there any time where this kind of doesn't work? Like where there's a block that makes this, the thing that we're doing now, kind of like not do as well,
No,
any condition?
because like if we start with fractions,
Excuse
we
me,
can multiply
Professor
here
Jones.
to get rid of the fraction, yeah.
We can choose any method to solve each equations, like the matrix or
Yeah, if you wanna do the matrix, you go right ahead, I'm not gonna do the matrix. Because I'm
Thank you.
suspecting no one likes the matrix. I didn't even like I don't like the matrix. There's a whole class, so if you don't like the matrix. Guess what we have here? There's an entire course that's fucking based around matrices. It's called linear algebra, it's after
Yeah.
Calc 3.
Oh, that,
I think you can
That's
take it
weird.
with Calc 3.
God, that's what the, it's,
That can stay there. That sounds like.
It's not bad, like it's, at that point, you're working with three-dimensional vector fucking calculus. Doing stuff where you're adding fractions together has become trivial, it's just time consuming. Okay,
that's perfect.
so we had a lot of options, we want to get rid of a variable in two equations. I noticed, and I think you guys might like this. All of the coefficients in the first line are fucking even. So if I divide by 2 or multiply by 1/2. This turns into x minus y plus z equals 4. And that makes this a lot easier to add multiples of in other equations. We'll call it, here's A, B, C. So 1/2 A is D. So now that we have all coefficients of 1. Heriberto, what letter should we get rid of, X, Y, or Z? We have all coefficients of 1, so it doesn't really matter which one we pick. Is your name Heriberto?
Sorry.
Were you gonna pick Y? Alright, let's get rid of Y. Why are we doing that, Davis? Why did you choose Y, Davis?
It's the negative.
Yeah, I like the negative too, but again, at this point, it wasn't gonna be a big difference, but not a lot of pain anyway, so we're gonna get rid of Y's. So if I wanna get rid of Y and B, I need 2 times this. So if I do 2D. I'm back to A and I already got it, so we already got that. So if I wanna get Y, rid of Y here, I need negative 3Y. So 3D. We'll call that E. That's gonna be 3x minus 3y plus 3z equals 9. Davis and Keith, I know you're both signed up for the NASA trip. Make sure you check your emails, you guys have a form you need to turn in by Friday. The test. Now, you might be able to fill it out and scan it and email it to her, or she's the Mesa director, if you go over to Mesa and ask where her office is. I think in the email it tells you what room she's in. It's basically like your permission slip. I don't know what it says on there, I'm gonna behave or whatever the fucking thing is. Alright, so what are we gonna do? We're gonna add A plus B. that's gonna get rid of our y. I get 7x minus z equals 10. And then if I add c plus e. I'm adding these two. 4x plus 3x is 7x. Negative 4z plus 3z is negative z. And negative 2 plus 9 is 7. What, Davis?
Seems like there might be a problem there.
Why? There is. Most people are not gonna recognize it yet. Why does it look like there's a problem? It's gonna show up if we keep going, but
Those things can't both be at the same time,
the left side is the same for both of them, but the right side is different, right?
so.
There's something going on. Like if I just subtract. This row from this row, 7x minus 7x is 0x. Negative z minus negative z is plus 0z. 10 minus 7 is 3. I get 0 equals 3. Which is false.
For E, wouldn't it be equals 12 instead of 9?
Yeah. There we go.
Oh,
Well, that still doesn't help us. So that, oh, actually it does. Thank you. I'm like, why do I have infinite written down? This is always true no matter what. I got 0 equals 0. The variables didn't matter. So we have infinite solutions. And when you get to Becker calculus, you'll be able to describe a little bit better what those infinite solutions are. Like when we did the 2D, it was all the points along a line. So there we could actually define the infinite points better. Here, you guys don't have enough practice with planes and shit like that to do that. And it's not really worth doing it. Here, it's just get you introduced to the idea. Again, easier than the fact the matrix method was gonna be. Next one. Go ahead and do this real quick. And I'm gonna recommend you eliminate X. And then we'll do it together in a second. Just because all the X's have the same coefficient, one of them is next. Oh, fuck that matrix up. Let that fuck it up real good. I reduced. I wonder if that did it. That did fucking do it. No, it couldn't have. That couldn't have done it.
I had a quick question.
Yeah,
Do we have to eliminate X first, or can we eliminate any one of the three?
you can eliminate any one of the three you want. X is already set up to be done easily.
Okay,
But like, I think you're gonna get to the answer faster if you eliminate X.
Oh, how may I help you?
okay, thank you.
You should encounter a problem. Just like the last one, but not 0 equals 0. You're gonna have 0 equals something else.
Well, and with that problem, though, since we have an equation like that. Can you multiply by whatever would set the. What, like you could multiply on the 3 there, if if R, B, and C were equal. Or R, B, and C were there, you could just multiply C by 3, and then you would have different things equal to 0. Right?
We're gonna have different things equal to 0 no matter what. I don't know what you like.
Oh, yeah, because it isn't actually so, yes.
So if I add, like, we've got A, B, and C. If I add A and B. I have 3y plus 4z equals 8. If I add B and C. I have negative 3y minus 4z equals 4. So that when I add them together. I get 0 equals 12.
But what if you had multiplied the bottom line by like -2? And add,
Then I would have still had an x.
uh,
So this is false. So there's no solution. Let's take a 5-minute break. And then we'll do a couple like enjoyable word problems. And then we'll tackle the 4x4 matrix.
Wait, we're gonna do that to matrix.
Alright, so next one we had a word problem. We have 3 points. 1, 2. 2, 1. And 3, -4. That's strong. We want to fit a parabola to this. Let's say we have reason to believe whatever this is from, the data is going to give us a parabola. Like y equals ax squared plus bx plus c. So like, let's visually look at what's happening here. I could say maybe there's a parabola that does something like this. I don't know where the vertex is, but it could be doing something like that. Maybe. Or I could have something where this is pretty spiky and it's going like that. But that looks maybe a little off. Maybe this is a little over here like that, so that it goes down. The point is, I can't really like looking at 3 dots, figure out what it is. But if I put the values of x, y into the equation. Put the points into the equation. And to make it easier, I'm gonna move the y to the right side. I'm gonna say equals y. I don't know what a is, but I've got x. I'm doing the 1, 2 first. 1 squared plus b times 1 plus c equals y, which is 2. So my first equation is gonna be a plus b plus c equals 2. That was plugging in 1, 2. If I plug in 2, 1. I have 2 squared here. I have 2 there. And my y is 1. This becomes 4a plus 2b plus c equals 1. Does that make sense what I'm doing here? And then we'll do the 3, negative 4. And you get 9a plus 3b plus c equals negative 4. We now have 3 equations with 3 unknown quantities, a, b, and c. And we can solve them and find out what a, b, and c are and plug them back into the equation. And we'll have the equation for the parabola. It's pretty fucking slick, right? What? That's fucking slick, right? Jackie's back there. Davis is like, I'm not fucking impressed.
Still trying to figure it out.
Does it make sense what I did?
Yeah,
I was plugging because this is x and this is y. I'm just replacing the x and the y.
so we could rediscover if we had just those, we could do the thing we just did in order to find the original equation.
Yeah, and that's what we're gonna do. We're gonna find this equation right here. Because in reality, life doesn't give you the equation.
Yeah.
You get the data points. We were just talking about this. You get the fucking data points and you're like. Now, I'm assuming this goes, I know it's not a line. Because the points are not in a line. Right? They're not in a row. So it's definitely not a line. So the next one up is parabola. We go from an x to an x squared. Now, that may not be the best thing, but let's say we know the data follows a parabola. And maybe it's a trajectory. And you measured the height at an x distance, 3 different points. You got like a tracking beacon on the motherfucker, but it only pings every second or so. So you have like 3 data positions, but you know it's following a parabola.
Yeah, maybe if you were like watching the ellipse of a comet, and you could only catch it at certain spots.
Submarines,
Or
the fucking radar ping,
sonar things, yeah,
sonar ping, it only shows the position.
we get a few shots,
You only get a few shots.
or everything you see is dead.
Right.
It's freaking nuts.
All right, so let's eliminate a variable here.
A.
Jackie said A, we're eliminating A. So I'm gonna. Ooh. I'll call this D, E, and F. I don't wanna use capital A, B, and C. So I'm gonna do -1D, just to write down what it is. So if I wanna get A, rid of these two with the A. I need -4D, which will be -4A minus 4B minus 4C equals -8. So that when I add -4D plus E, my 4A and my -4A go away. I have 2B minus 4B is -2B. And I've got C minus 4C is -3C. And 1 minus 8 is -7. All right, we want to do that with F also. So F, I need -9D. And I'm gonna add F plus -9D or -9D. My A's go away. I have 3B minus 9B is -6B. C minus 9C is -8C. And -4 and -18 is -22. All right, which letter looks like it's easier to eliminate here? I'm gonna say B also. Why?
Because 6 is small. Or because you only have to do it once, you want to do it twice.
6 is a multiple of 2. Which means I only gotta multiply one of the equations by a number. So let's multiply. Let's call this G and H. If I multiply G times -3. I am gonna end up with 6B. And that'll cancel the -6B on H. God, those look like the same thing. 6B, okay. I'm doing -3 times -3 is +9C. And -3 times -7 is +21. I'm gonna rewrite H underneath it. Just for making adding easier. C equals -1. All right, let's plug this into one of the other equations. Doesn't matter which one we plug it into. I'll fucking put it right into H. Well, it should be one of our 2x2s. If I subtract 8, I get -6B equals -30. And I shifted to a capital B, I don't know why, I'm gonna go back. B equals 5. Then I'm gonna go back to my top line, A plus B plus C equals 2. A plus 5 minus 1 equals 2. A plus 4 equals 2. So A equals -2. And my parabola is -2x squared plus 5x minus 1. Thoughts? Questions? I use this for D&D, like, it's been a year and a half, 2 years. My buddy's making a spreadsheet and certain, like, there's at 3 different levels. Something changes, and he wanted to have a nice little equation that he could put into Excel. So that it knew exactly what to use, and I'm like, well, and I know it's not a straight line. So it's a parabola. And I was really proud of myself, because I wasn't thinking like this at all, it was like out of nowhere. How do I apply this? I'm like, there's 3 equations, I don't know what they are, but let's do this. And I fucking did it, he plugged it in, like he tested all the different things, like, yep, works great. Everyone good? Circles. We have 3 points on the circle, 3, -1, -2, 4, 6, 8. Find the equation of the circle. I'm gonna give it a little sketch real quick, just to see if I can figure out what the hell this looks like. Now I'm guessing something like that, which would put the center around there. We do the same thing that we did with the parabola. So the 3, -1, we have 3 squared plus -1 squared plus d times 3 plus e times -1 plus f equals 0. So this is 9 and this is 1. I have 3d minus e plus f equals -10. I'm just plugging in the x, the 3, the y is the -1, and I'm cleaning it up. We'll do the same with the other 2 points. We have 4 plus 16 minus 2d plus 4e plus f equals 0. plus 16 is 20, and I move to the other side, I got negative 20. This is 100. So if I move to the other side, I've got 60 plus 8e plus f equals negative 100. You guys get something like that? Okay. So that's what we're starting with. What letter do you guys want to get rid of? F, okay. So let's get rid of F. E is a good choice too, because we got a negative one right there, but F, they're all the same. So all I gotta do is pick one and multiply it by a negative. And add it to the other two. I'm gonna do the first one. Let's make that into negative 3D plus E minus F equals 10. Maybe I'll number these. 1, 2, and 3. This will be equation 4. So if I add 2 plus 4, I get 6 now. We are gonna have negative 2D plus negative 3D is negative 5D. 4E plus E is 5E. Negative 20 plus 10 is negative 10. And if I add 3 and 4, fuck it, I am gonna call that equation 6. Even though I skipped a 5. And 3 plus 4 is 7. Add these up, 60 and negative 3D is 3D. 8E plus E is 9E. The F's go away. Negative 100 plus 10 is negative 90. You guys with me so far? Now, I don't particularly like the coefficients here, but I can see on this equation, everything's a multiple of 5. And on this equation, everything's a multiple of 3. So if I divide by 5, I get negative D plus E equals negative 2. And if I divide this one by 3, I get D plus 3E equals negative 30. I just did that to get lower numbers in front. But in this format, it conveniently set up to add these together, didn't it? I got lucky with that. That was an unintended benefit. So if I add these up, I get 4E equals -32. So E equals -8. Plug that in here. -D minus 8 equals -2. So -D equals 6. So D equals -6. And if I put those into the 3D one, 3D minus E plus F equals -10. I have 3 times -6 minus -8 plus F. This is -18 plus 8 plus F. F minus 10 equals -10, so F equals 0. So the equation is. Can we get it to see if we, like, this looks like the right circle? If we put it together, we can complete the square. Half of -6 squared is 9, so we'll add 9 to both sides. And half of -8 squared. -4 squared is 16. So plus 16. I get x minus 3 squared plus y minus 4 squared equals 25. So the center is 3, 4. That looks about right.
And the radius would be 5.
And the radius is 5. This is 3, -1. That's a distance of 5. So my sketch was not too bad. How's that for some cool shit? Ready for more? You know where this actually comes up? I bet this comes up in earthquakes. The seismology machines are only at fixed spots. So when an earthquake happens, they measure the distance, or they measure how, like, they measure the time each place records it, and they're able to calculate how much time it was from the earthquake, basically, by doing some calculations. But like, you have an XY coordinate for each of them and a timestamp for them. I bet they do that there. You can also draw 3 circles and triangulate it that way. But you guys ready for more? Does anyone need that longer? Alright. Go big or go home. Oh, yeah. Oops. Let's put this right here. I'm gonna do it in red so it stands out. You know what? Just redo the damn line. And we got one more. Four equations, four unknowns. This is a 4x4. So Jackie had mentioned she was doing the homework and at some point, like, they didn't give, there was missing variables.
It wasn't that it was missing variables, it's. I was so used to doing it the echelon way where like the variable would by itself, it makes sense. As opposed to where like. There's X, Y, and Z in every row, yeah, so, but now that like I.
Here, we don't have one with the Y. There's not an X, Y, Z, W in every row. There's a Y missing on this row.
Right.
So like if you're doing it and you wanna have a Y there, you can always put in 0 Y.
Okay.
So like if you're doing the matrix form, that's what you would do. You would put in a 0 in that spot. But I'm gonna cross that off because we don't have it and. The pattern, what we wanna do here is get a 4x4 down to a 3x3. Get that down to a 2x2. Down to. A variable equals a number. And then backpedal. Y's look like they're pretty good to get rid of right now. Cause one of them's already missing. Does that seem reasonable? So get rid of Y first. So if I add, let's call this A, B, C, and D. If I add A and D, some Y's go away. And I get 4x plus 7z plus 8w equals 19. And I already have B, so I'm gonna use that. X minus 2z plus 7w equals 11. So we'll call that E, this is still B, I don't need to change it. F, we need to get rid of it, we need to do another one. We've done A and D. We've done B, we need to do something with C. So I'm gonna do C plus 3D. So if I do 3 times this, I get 3y. And the negative 3y's will cancel. So 3x and 6x is 9x. Z and 12z is 13z. 5w and 3 times the 4 is 12w is 17w. And then 8 plus 3 times that is 38. All that F. And I'm gonna put a box around this, because this is our 3x3. We have eliminated a variable, we're down to 3 equations, 3 unknowns. It kind of breaks up the page a little bit, helps me track what I'm doing. I got a really good candidate to get rid of here too. What is it? Yeah, let's get rid of X. And why do you like X? We got one by itself. Work harder or smarter, folks, not harder. Find the one that makes your work easier. So if we use this one, I can add -4 of this one to that one and get rid of the X's, right? So I could do -4B plus E. So if I do that, I'm gonna have, that'll be a -4X. That's gonna be an 8Z. A -28W and a -44, that's what I'm adding. I just did -4 times B. Now I need to add that to E. 4X, -4X goes away. 7Z plus 8Z is 15Z. 8W minus 28W is -20W. And 19 minus 44 is -25. Oh, that's nice. There's all multiples of 5. We're gonna simplify that later on a little bit, I'm thinking. And now if I do -9 of B. And I add that to F. Let's write down what -9 would be. I have -9X plus 18Z minus 63W equals 99. That's -9B. That's what I'm gonna add to F. So my X's go away. I've got 13 plus 18 is 31Z. Ew. 17W minus 63W is -46. And 38 plus 99 is 137. Okay. So we can resort to fractions or we're gonna have big coefficients. I'm okay with big coefficients if you are. First thing I'm gonna do though is I'm gonna divide this by 5.
Is it 137 or is that supposed to be -19 plus 38?
It should be -99, you're right. So that should be just 37, thank you. That makes some numbers smaller. If I divide by 5 there, I get 3Z minus 4W equals -5. All right,
Would it be 37 or would it be -61? Because -99 plus 38, that'd be -69.
I'm over here just fucking being a scrub. Yeah, -61. Just fucked that all over, didn't I? Try to speed up everything. Alright. We're down, let me put a box around this, we're down to 2 by 2. And it ain't getting prettier. I'm gonna eliminate Z's by, let's do the opposite here. Let's multiply. Let me get out the red pen. So we'll multiply this one by, I don't know, -3. And we'll multiply this one by +31. So -3 times 31 is -93Z. -3. Wait, what? -3 times 31 is 93. -93. I didn't write it. 3. And -3 times -46 is 158,
138.
138.
138. Thank you. And -3 times -61 is 183. -120 and 4 is -124 W.
Yes.
And this is -155. All right, we add them up. 14W equals. Please tell me that's 28.
Yes.
Fuck yeah. We get W equals 2, good, no fraction yet. All right, now we're gonna backpedal. I'll plug that in there. So 3Z minus 4 times 2 equals -5. 3Z minus 8 equals -5. 3Z equals 3, Z equals 1. That's beautiful. That's beautiful, folks. Let's take both of these. Plug them into B. And I have X minus 2 times Z plus 7 times W, which is 2. Equals 11. X minus 2 plus 14 equals 11. X plus 12 equals 11, so X equals -1. And now I'm gonna plug them into D, because D's already got Y by itself. So 2 times -1 plus Y plus 4 times Z plus 4 times W equals 10. Is that Y equals 0?
Yes.
So our X, Y, Z, W solution is -1, 0, 1, and 2. And you just let's just do that 4x4 matrix. Now you can see, like, if we keep going up, like if I had like 6 equations or 10 equations. This we gotta go like 10, we gotta 10 by 10, we gotta go to 9 by 9, 8 by 8, 7 by 7, all the way down, and then work all the way back up. At some point, the matrix, even with dealing with the fucking fractions, is easier. You know what I mean?
So is it like the bigger you go, the matrix is like simplifies it for you, or?
Well, yeah, because first off, you don't have all the letters running around. And you can kind of, once you change like the top row to a 1, you can change all the other rows to, like the rows below it, to have a 0 below it relatively quickly. It's multiplication and then addition. Any questions? I think we're going home early.
Yes.
Let's go home early. That's the best news Lauren's heard all day. She's giving me the fucking thumbs up. So I thought you guys might like that method better than the matrix. In light of that, I don't know if you noticed, the homework has been changed to be due next Thursday, along with what we're covering on Thursday, which is the ellipses and hyperbolas.
Perfect.
So yeah, a week extension on this. You guys have a good night. Thank you. Later.